All right. Today is the 27th. Are you guys all dressing up for Halloween?
Oh yeah, I'm gonna be here for Halloween.
Okay. Well, that settles that. So this is your first. I should have put up at the top of this. Holy crikeys, boys. Woof. Hey, homies. I should have put at the top of this practice quiz number one. I didn't, but do know that there will definitively be a practice quiz number two. And then your quiz will be Thursday. So I won't help you as much with the second one, but since I threw a couple of new concepts at you, I figured I should probably do the right thing here. So this is question one on the first practice quiz. And we have a function. What do you guys notice about question one and two that's different from our past experience? And you guys are awesome. Like you're total math studs. You're not going to struggle, but I would be remiss if I just assumed that you'd be like, oh, I know what to do. So there's the polynomial. You'll notice right away it's a little different because it's a fourth degree, but that's okay. The goal is always to be able to chip it down to where I can work with either the quadratic formula or some sort of quadratic. And since it's a fourth degree, and I'm giving you two zeros, then you're essentially going to chip two layers off of the stone, which will get you down to where you want. So the first zero is -6. So we're told that, and by the way, the order in which you do these is irrelevant. So we're told that -6 will work, and we're also told that 4 will work. So the order is irrelevant. Which one would you guys like to chip first? -6 it is. So we are still going to start with our purple numbers. So we're going to do 1, -2, -38, 84, and 144. And then I heard -6, so that shall be the one that we will use first. And so we are assuming that there's going to be a 0 right here. So it's okay. If you know what's coming, you might as well put it in there. And then you do your synthetic thing. So you drop the 1 and get started. So -6, add those, -8, multiply those. Yep, add those. Yep, multiply those. -60, add those, multiply those. -144. Then when you add those, you get your 0.
Now, the other L bracket, you put the 4 in there.
Good job. But the new upside down division comes off of these ones. So this is kind of more what your upper level, college-y level synthetic problems start to look like as we start chipping down, but we're using the new numbers as our purple numbers. They're not purple on the board. Maybe I should have thought that through, but regardless, we have made like a new problem to do. And so we're going to build down off of what normally are our quote unquote answer numbers, and we're just going to keep chipping. And this time we're going to use the other one that we presume is going to work, the 4. And again, I expect a 0 right here. All right. And so we go again, drop the 1 and multiply 4. Add. Everybody with me?
Yep.
-4, multiply. -16, add. -6, multiply. -24, and there's that 0. So we got to our destination. It was just a little bit of a longer route, but it's kind of fun when you get to do the stacks, when you do stacks of synthetic division. But we are now down to our like old familiar comfort zone. We're left with 3 numbers, which are always enough, the right amount to make a quadratic. And so we're going to have x squared minus 4x. Is that factorable? Yeah. I share your sentiment. I don't think so either. Like if you're good at factoring, you know that we could do a 1 and a -6, but those would add to -5, and we could do a 2 and a -3, but those would add to make -1. So there's no way around that we're going to use the quadratic formula here. In the next little unit that we do, we're actually going to do a unit after this where all we talk about is quadratics for like weeks. And then I'll go over something that I think I touched on in Algebra 1 called completing the square. I didn't want to introduce it during this. I didn't want one more thing to gum up your minds, but this would be a perfect time for completing the square, by the way. And if you're a math nerd, you'll love completing the square. It's super fast, but let's not go down that road today. So let's do what we're familiar with. A is 1. B is -4, and C is -6. All right, let's do it. So what does X equal? 4. Yeah. And again, good job turning it to plus right away. That's really good sort of foresight there to just, get right to it. You know what's coming, get it done, clean up your work. And then that's all divided by 2. Are these going to be rational, irrational, or imaginary? Irrational for sure. Definitely not imaginary because 16 plus a bunch is a positive bunch and like there's no way we're going negative. And it's irrational because inside the root, we're doing 16 plus 4 times 6, which is 24. And what is 16 plus 24? 16 plus 24. 40. So we do see that it's irrational because 40 is not on our list of square rootable numbers, but we know how to break it down. How are you going to break down root 40? Yeah, root 4 and root 10, which makes 2 root 10. So I'm going to get rid of that square root of 40. You pop the new guy in there and triangle it down. That was a good looking Dorito for first thing in the morning. Divide those all by 2. You will get a 2 and a 1 and a 1. So the answer would be what? Or the answers, I suppose. X equals 2 plus or minus root 10, comma, X equals, comma. There you go. So it's really not that big of a leap. I mean, you guys were like riding the struggle bus, then that might be like, oh no, what do we do? But you realize it's just what we've done with just one additional sort of bonus fun step at the beginning. So that'll get you through problem 2. Problems 3 and 4 are what you're already familiar with. Let's go through problem 5. And let's not even wait. Let's just do it. Again, you'll notice it's a 4th degree polynomial. I'll just copy it on the board so anyone watching the video will know what in the heck we're doing. So we have 4 of those, minus 4 of those, minus 17 of those. That is an ugly 2. Let me fix that. Plus 9 of those, plus 18. So we are going to use the rational root theorem. The difference this time is finding 1 isn't going to be enough. And you can kind of tell that again. I know it's pretty new today, but because this is a 4th degree, we really want to chip 2 layers off to get it down to a 2nd degree. That's the goal. And so we're going to start with the rational root theorem just like we're used to. So we're going to do the factors of 18 first. And again, notice I didn't include the plus sign, not like it matters, but I mean, I don't worry about the signs because when I do my list, the positive negative accounts for that. So don't worry about that. So I'm going to do the factors of 18 on top and the factors of 4 on bottom. So what are the factors of 18? So 1, 2, 3. 4 cannot go into 18. I mean, it can 4.5 times, but we don't want that. Who goes with 2? 9. There you go. So, yeah. You all right, bud?
Yeah, I'm good.
Okay, cool. And then on the bottom, we're going to do all the factors of 4, which are 1, 2, and 4. So we're going to take a moment. This is generally, it's a process. When you have multiple numbers on the bottom, it's a thing. So I like to go through and do all of the top numbers as whole numbers first, because the 1 on the bottom tells me that I'm going to have a bunch of whole numbers. You always will, right? So we're going to say there's positive and negative 1 over 1, positive and negative 2 over 1, positive and negative 3, again over 1, positive negative 6, positive negative 9, and positive negative 18. And I'm probably going to run out of room, but let's see. There will be some redundancy. So we'll see if I can fit all this in before I get to the edge of the board here. I don't like my chances, but we'll find out. So you would understand at this point that the 1 that I just put an X through is done. So I'm doing this in a little bit of a different order than I normally do. It must be just a weird morning or something. But now we're going to go through and we're going to take all the numbers across the top and work them with a 2. So it doesn't really matter, like, but I would pick a system and like from the beginning of a problem to the end of that same problem, be consistent with like how you're organizing this so you don't overlook one. So now we're going to take 1 over 2. And then we're going to move across and do 2 over 2. But we don't have to do that, right? How come? Because it's already on our list, right? But then we do have to do 3 over 2. That is a new, unique possibility. And what's after 3 over 2? 6 over 2, right? Which is 3, which we already have. And we can move across to the 9. And that will be unique, right? Positive and negative 9 over 2. And then the last one is positive negative 18 over 2, which again is already there because 18 divided by 2 is 9. I like my chances. I think I'm going to fit these bad boys in here. So we are done with the 2. And now we're on to every possible fraction that uses 4 as its bottom. So positive negative 1 over 4. Who's after 1 over 4? 2 over 4, which we already have, right? What's after 2 over 4? Which we don't have. After 3 over 4? Six over 4, which we already have, because there's 6 and 4 reduced to 3 halves. And what's after 6/4? 9/4, which we don't have. And look, I just barely made it. And we know the last one's going to be redundant because 18/4 reduces to 9 halves, which I just talk about cutting it close there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 24 possible rational roots here. So, all right. So in case you weren't having enough fun already, now we have to find 2, right? But extra bonus. We get to find 2. We get to find 2. Nice t-shirt. Kudos on the fashion choice today. Way to go. All right, so we're going to bust out the coefficients now and make our template. So we have a 4 and a negative 4 and a negative 17 and a 9 and an 18. And let the games begin. Let's see if Mr. In tune with the universe has it. What do you want to try there, hands team?
Something very close to 2.
Hey, you guys want to see a trick? Do you like tricks?
Yeah.
I got one for you. Look at the numbers I'm underlining and kind of just for shiggles, add them together. So just follow with me here. What is 4 minus 4?
0, 0.
What's 0 minus 17? Negative 17 plus 9. Negative 8 plus 8, 18 is 10. So you know one's not going to work. Did I tell you? I told you that last week, right? That you don't. Oh, I didn't? I thought I did. Yeah. So 1 you can always test by just adding the numbers at the beginning together because 1 won't change anything, right? Like you stick ones in place of X's and you're just going to keep getting one for that part. So you're really just adding the numbers together. So we don't have to check one. What do you want to start with? Sorry, I interrupted you. What a random choice. All right. Oh boy. All right then. So what's 3/2 of 4?
6.
6 is correct. If you still don't know how to do that, you really need to get in and see me so I can show you how to do the quick mental hook, divide, multiply. Like it's super mega quick. Add -4 plus 6, 3/2 of 2. -17 plus 3. 3/2 of -14. Did I put -4? I meant to put -4. That's my bad. Apologies. I was a step ahead of myself there. What is -21, you say? I think so too. -7 if you divide and then multiply and then add those together, what do you get? -12. And then multiply those together. What?
So,
Okay, yeah, now I'm officially scared of you. I'm gonna go out of my way for the next like, I don't know, 6 months to just not anger that man over there because I'm worried now about the powers that you possess. Yeah.
Well,
Go-
no,
go-
it could be two because
Did you?
it was too big.
Too big? Was that a pun?
Yeah. So then, and it couldn't be one, so it had to be a fraction in between one and two.
Okay. Good. We got one. So, by the way, I did want to tell you that the same number can work twice. So, I don't know if you want to. Like, I don't actually remember the answers because full disclosure, I wrote these problems like last September, so it's been a minute. But the same number can work twice. So, what you want to do now is just like we did in problem 1 is scaffold down and rebuild. And Parker, are you feeling it? Do you want to try 3/2 again? Go ahead, Mr. Mental Powers. Anyone else? Or are we all scared of Parker now?
Oh, wait, we do a two step.
Yeah. See what I mean? This is why I'm going over this with you, is because we have to do two. So we found one, which is rad. So we found 3/2. So in our final answer, we're going to write x equals 3/2. But we need one more.
Two.
All right. The Mr. Telepathy has spoken, and we're going to try 2. So that's 4.
Oh.
It's an 8. No, what does it work?
Oh.
This is 20.
-2.
Well, just stop for a second. 2 plus 8 is 10, right? 2 times 10 is 20. -14 plus 20 is 6. 2 times. What is happening right? Why don't get you? This is what is the what? What?
Well, I was doing -2 first. I always do negatives first.
So we got him. And by we, I mean Parker got him. By the way, if you take a random shot, I gotta figure this out. I don't want to say it on recording and be wrong, but the probability of picking 2 correct out of 24
Which would be 48.
is really no else. It's 12 times 2. It is crazy. So hey, I'm moving on. I don't know what to say right now. So good job. Thanks for that. You saved us a lot of time. So our quadratic is going to be 2x squared plus 5x plus 3. And is it factorable? If you use the test and multiply this number and this number, 2 times 3 is 6, right? Are there numbers that multiply to make that and add to make that?
Yeah.
Then it's factorable. So we would be wise in this case to just save the time I mean, I like the quadratic formula. It's not like it's hard or anything, but it's still nice to not have to do it. And this isn't going to be very upper level factoring, right? I mean, it's 2x and 1x, and we know they're both pluses. And it's like, ooh, should I put the 3 before the 1 or the 1 before the 3? Obviously, you don't want to put the 3 on the far side because it'll pair with the 2 and you'll overshoot your 5. So you want the 3 here and your 1 here. So this would be an example of a problem in which there are 4 rational solutions because of the factorability. So what answer would we get out of the one that I'm underlining in red? X equals what? -3/2. Nice job there, folks. And what answer would we get out of the purple one? X equals -1. And then we got to go back to Mr. Whatever over here. And what were his again?
2.
2 was one that he found. And what was the other one? Yes. So before I shut up and stop the recording, just let me say what this means is back when we were sitting around trying to figure out what numbers to try, -3/2 would have also worked, and -1 would also have worked, just for the record. The pathway, like the numbers we would have encountered along the way, would look different, and the quadratic that we got at the end would have been different. But at the end of the day, these 4 numbers at the bottom of the screen, we were going to get them out. The order in which we get them out is irrelevant. Okay. So I hope you understand that to some extent, that there were 4 out of 24 that would have worked. Still tremendously good guesses. So you guys have any questions for me? For the remainder of the day today, you'll work on this. Tomorrow, I'll probably give you a new one, because I think what I'd like to do is get both practice quizzes out today and tomorrow so that you have tomorrow and Wednesday to tidy up your loose ends before Thursday. What I'm saying is I won't wait till Wednesday to give you the next one because I feel like that's not enough time. So, and by the way, I haven't hit publish yet, but I do have the answer keys finally up for assignments 14 and 15. So if you would before I don't know, before the end of the day or whatever, get those graded and make sure that you got all those. There were 14 problems, or yeah, 14 in total, I think. Get those graded, please. Do you have any questions?